Now consider here a situation in which we have given here one angle plate and one simple plate, and we want to do the arrangement as shown in figure. That is, we want to weld here this angle plate to the vertical plate. In that case, you can do the lap welding at the top point and at the bottom. So throughout these lines we can make the welding, that is the fillet welding. Here also we can make the welding that equal to fillet welding. In the cases that we have done previously, the force exerted will be the passing through the centroid of the system. So we have to first locate here what is the centroid of the L shape of the plate, and then you have to pass the force through that centroid. We will show here two view. One is the edge view, that is this side we have plate 1 and we have angle plate, and here we have done the fillet weld. On this view from this side, you can visualize the plate 1 and the plate 2. Let's say here the fillet weld on the top has a length equal to LA, and at the bottom the length of the weld equal to LB. The center of gravity of the weld group is at this point. This one is called as center of gravity, and through this point the force F is passing. So it is compulsory here that the force must pass through the center of gravity of the weld group system. Let the top weld at a distance of A from the line which is passing through the center of gravity, and the bottom weld at a distance equal to B from the center of gravity. Because of the two uneven side of the angle plate, the CG will shift near to the corner. So LA represents here the length of the weld at the top, LB represents here the length of the weld at the bottom. Total length required is LA plus LB. Let's say the distance A is the distance of the top weld from the gravity axis, and distance B is the distance of the bottom weld from the gravity axis, and let's say F is the resistance offered by weld per unit length. The unit of F you have to use as Newton per mm. So whenever you have to weld the angle plate on plate, then the member is subjected to axial loading but unsymmetrical welded joints. Since here F is the resistance offered by the weld per unit length, so the top resistance will offer a resistance in the opposite direction of the force shown here. Let's say that value will be equal to Newton per mm. So you have to multiply it by length LA, that will be equal to F multiplied by LA. So we'll develop the FBD here. In this case, we have this dotted line represent the gravity axis through which the external force F is passing. If F is the resistance offered by the weld per unit length, then the top weld carry a load that equal to F1, and this value of F1 is F, which is Newton per mm, and LA in mm. So total force is F multiplied by LA. And at the bottom, the length of the weld is equal to LB, so this will offer a resistance F2, which will be equal to same as the resistance offered by weld per unit length equal to F. Corresponding length will be equal to LB. So you have to analyze this figure. So we have two governing equations here. We can apply summation of x equal to 0, that is the value of F is equal to F1 plus F2, and second equation we can apply the moment equation. You can take the moment about the point G. So we have two equations formed here, and therefore we are comfortable to find out the value of LA and LB. So right now we have two unknown with the length on the top weld and the length on the bottom weld. The top weld will fail in the shear, so we can calculate F1 as a load carried by the top weld as in shear we have area is equal to T multiplied by the length of the weld that equal to LA, and is multiplied by shear stress tau. The throat is same as equal to 0.707 multiplied by the leg size equal to H, and the length of weld equal to LA multiplied by tau. So we can calculate F1 as F multiplied by LA, or you can calculate it as 0.707 H multiplied by LA multiplied by tau. So let's say this one is equation number 1. And if you are knowing here the resistance offered by the weld per unit length, then you can use the value of F multiplied by LA to calculate the load carried by the top weld. Let's say equation number 2. Similarly, we can calculate here the value of F2, which is based on F multiplied by LB, and the second value we can calculate the shear failure. So F2 is the load carried by the bottom weld is F multiplied by LB, almost copy of this. If it is fail in shear, it will be tau multiplied by the throat thickness multiplied by the length of the weld at the bottom is equal to LB. Throat is same as equal to 0.707 times H multiplied by LB multiplied by tau. Any of these two equations we can use to carry out the value of F2. Now we have two unknowns here, one is LA and LB. Since we have two unknown LA and LB, so minimum number of equations you have to form is equal to 2. So this one is a parallel force system, so we can form the two equations. One is a summation of Fx equal to 0, and second equation we can take the moment about the point G. So we'll apply here for summation of Fx equal to 0 rightward. In that case the force F is positive, F1 is acting leftward is negative, and F2 is also acting leftward is negative. So we have F is equal to F1 plus F2. So if we apply sigma Fx, then F is positive value, F1 is negative value, and F2 is negative value. So we have F minus F1 minus F2 must equal to 0, or we have F is equal to F1 plus F2. This time we'll use the equation 1 and the equation 4 to calculate the total length LA plus LB. In both of equation 1 and 4, 0.707 multiplied by H multiplied by tau is a common. So we have F is equal to 0.707 multiplied by H multiplied by tau, and then we have the sum of LA plus LB. But we are interested in the individual value of LA and LB. Here we have developed the equation for length, that is LA plus LB. So we have to use one more equation. So to find the value of LA and LB, we'll select the gravity axis and we'll take the moment of all these forces above the gravity axis. But the force F is passing through the gravity axis, that is through point G, so will not cause any moment because the perpendicular distance for force will be equal to 0. The force F1 will make an anticlockwise moment, and the perpendicular distance between F1 and the gravity axis is equal to A. Secondly, the force F2 will make a clockwise moment, and the perpendicular distance for F2 is equal to B. So this time we'll take the sum of moment of all forces above G equal to 0. Either you take clockwise positive or anti-clock, whatever it may be, you have to mention it first. So I will say here the clockwise I will take positive. As far as the force F is considered, we have perpendicular distance is equal to 0. So this force has a perpendicular distance equal to 0, will not cause any moment. F1 will make an anti-clockwise moment. So anti-clockwise will take it negative. We have F1 multiplied by the perpendicular distance is equal to A. And F2 will make a clockwise moment about point G. So that will take as positive. So we have F2. For the force F2, the perpendicular distance between the gravity axis and F2 is equal to B. So we have multiplied by B. Sum must equal to 0. First term is already 0. So in this case, we have F1 multiplied by A must equal to F2 multiplied by B. At this stage, we can replace F1 equal to 0.707 H multiplied by LA multiplied by tau, or for simplicity and for quick calculation we can write as F into LA also. So we have F1 is replaced as F into LA into distance A. F2 we can replace as F into LB, or 0.707 H LB into tau. So this 0.707 H tau will get cancelled here also. So it is better to use a simple term here, that is F multiplied by LB multiplied by B. So F term will be get cancelled here. So we have already find out here the sum, and now we know the relation between the individual value. So in this case we have LA is equal to LB multiplied by B divided by A. So from equation number 5 and equation number 6 we can find out the individual value of the length LA that is to be carried out on the top side, and LB, that is to be carried out on the bottom side. In this fashion, we can solve the numerical which is based on axially loaded unsymmetrical welded joint. So that is nothing but the angle plate is welded on vertical plate, and we need to find out the value of LA and LB. So this equation is familiar to you, that is F1 is equal to 0.707 H multiplied by LA multiplied by tau. Similarly, we have F2, which is the load carried by the bottom weld, is 0.707 H multiplied by LB multiplied by tau. One equation you have to use the summation of force, that will give you the total sum LA plus LB, that is the total length of the weld required. And to find out the individual value on the top side and the bottom side, we can take the moment about the gravity axis. If you take a moment about the gravity axis, then LA multiplied by A is same as LB multiplied by B. So simple two equation you have to use. One equation is F is equal to the area on the top side plus bottom side. The area on the top side is 0.707 H and the length equal to LA. On the bottom side we have 0.707 H multiplied by LB, and we have to multiply it by shear stress. That is equation number 5. So very quickly we can write the value of summation of Fx, that is the value of F is equal to 0.707 H multiplied by tau multiplied by LA plus LB. Using this we can find out here the total length of the weld required. Then you can take the moment about the gravity axis. For that one I will give the clue. F2 multiplied by B is same as equal to F1 multiplied by A. It is nothing but the total moment about the gravity axis equal to 0. So two steps are required, equation number 5 and equation number 6, to find out the length on the weld at the top and at the bottom. An angle plate of welded as shown in the figure. So we have given here one angle plate and it is welded as shown in figure. We have given the two distance. From the gravity axis, the top weld at distance equal to 150 and the bottom weld at a distance equal to 50 mm, and the force is applied through the center of gravity axis. The allowable stress for the weld is 70 Newton per mm square, that is the value of tau is given. The angle is subjected to static load of F is equal to 200 kilonewton. Determine the length of the weld at the top and the force carried by the top weld. You have to take the size of the weld, that is the leg size you have to take as 12 mm. So here we are given the value of force F is 200 kilonewton and we are given the leg size H is equal to 12 mm. So we have H is equal to 12 mm and the shear stress tau you have to take equal to 70 megapascal. 70 megapascal. Let here F1 represent the load carried by the top weld and F2 represents here the load carried by bottom weld. The load carried by the top weld is fell under shear. So we have throat area is tau multiplied by the length of the top weld equal to LA multiplied by shear stress tau, and the throat length is same as equal to 0.707 of leg size multiplied by LA multiplied by tau, but we don't know the value of LA. So we need to calculate the value of LA here. Similarly, we have F2 is the load carried by the bottom weld of length equal to LB is given as 0.707 multiplied by leg size multiplied by LB multiplied by tau. Again, LB is also not known. So if I apply the equation sigma Fx equal to 0, so I will follow the same procedure that I have discussed in the derivation. We have this force is positive force, F1 is negative, F2 is negative. So we have F minus F1 minus F2 equal to 0, or we have F is equal to F1 plus F2. F1, F2 we can substitute from these two equations. 0.707 multiplied by H multiplied by tau is the common quantity. LA plus LB we can find out. So in this case we have F is given as 200. So we have 200 multiplied by 10 to the power 3 will be Newton is equal to 0.707. Leg size H is equal to 12 and we have shear stress tau is equal to 70 multiplied by LA plus LB. Solve this, you will get LA plus LB, that is the total length of weld from the top and bottom is close to 336.7 mm. Now we want to find out here the individual value of LA. Then we calculate the value of F1. For this purpose, we'll take the moment above the center of gravity. Force F passing through gravity will not cause any moment because the perpendicular distance is 0. F1 will make anticlockwise moment, and for F1 perpendicular distance is A, which is 150. F2 will make a clockwise moment which has a perpendicular distance equal to 50. F1 and F2 we can substitute from here. In that case 0.707 multiplied by h multiplied by tau is get cancelled. So here we left here with only LA multiplied by A. A is equal to 150 is equal to F2. F2 only LB is left and the distance B is equal to 50. Since we are interested to find out the value of LA, that is the length of the top weld, so it is better to replace LB in the equation 1. So we have LB is equal to 150 divided by 50, that equal to 3 times of LA. So this one is equation number 2. So we'll put this value back, we'll get LA plus LB, which is equal to 3 times of LA is equal to 336.7. So we have 4 times of LA is equal to 336.7. So in that case we have LA is equal to 84 mm. 84 mm, we have two choices here, so you have to confirm the choice A or choice B. For that one we need to find out the value of F1. So we have F1 equal to 0.707 multiplied by H, which is equal to 12, multiplied by LA, which is equal to 84, multiplied by shear stress is equal to 70. So in this case we will get the load carried by the top weld will be equal to 50 kN. So length is 84 and the force is 50. So choice A is correct. How much length of 10 mm fillet, that is H is equal to 10, is required to weld a long side ISA angle of 150 by 75 by 10 to a steel plate with a side weld only? A static load of 125 kN acts to the center gravity of the angle section, which is 53.2 mm from the short side. So this one is the short side here, and we have short side equal to 75. So this length is equal to 75 mm. This one is the longer side, so this side is equal to 150 mm. It means that the distance A will be equal to 150 minus 53.2. So we have 150 minus 53.2. Indirectly he has given us the distance of the top weld from the center of the gravity, that is the gravity axis, is 96.8 mm, and the allowed load per mm of the weld length is 665 Newton. So we have given the value of F, which is equal to 665 Newton per mm. In this case we have to find out here the how much of 10 mm fillet weld is required to weld the long side, that is this side, which required a weld length equal to LA. Shear stress is not given, rather than we have given here the allowable load per mm, which is 665 Newton per mm. According to that we will define the force F1 and F2, which is resisting the top and the bottom weld. So let's say F1 is the force which is resisting on the top weld and F2 is the force at bottom weld. So we can calculate the value of F based on F. You have to simply multiply it by length, it will be answer will be in Newton. So we have F1 is equal to load carried by the top weld is F multiplied by LA. In the similar way we can calculate F2, which one is the load carried by bottom weld, is F multiplied by LB. So again we have two unknown, one is LA and LB, and we have two governing equation. First equation is summation of Fx equal to 0. So we have F is equal to F1 plus F2. So we have summation of Fx is 0. In that case the force F is positive, F1 is negative, F2 is negative. Force F we are applying is 125 kilonewton. So this value of force is 125 kilo Newton. F1 plus F2 we can replace as FLA plus FLB. So we have F is equal to, F is common, multiplied by LA plus LB. We have F is equal to 125 kilo is 10 to the power 3. F value is equal to 665 multiplied by LA plus LB. Total weld length LA plus LB is equal to 188 mm. Now the second equation is known to us. If by taking the moment, we know F1 multiplied by A is same as F2 multiplied by B. So we have F1 multiplied by A is equal to F2 multiplied by B. F1 is F into LA. F is get cancelled. So we have LA into A is equal to F2. We have F is get cancelled. So we have LB multiplied by B. Here we don't know the value of LA and we are interested to know the value of LA. The distance of top load from the gravity axis is A is 96.8. Length of bottom weld is LB and the bottom weld from the gravity axis at a distance equal to 53.2 mm. So it is better to solve for LB. LB will be equal to 96.8 divided by 53.2 is 1.8 times of LA. So in the equation 1, if I substitute for LB as 1.8 times of LA, we can find out the value of LA. So we have LA, LB is replaced as 1.8 times of LA is equal to 188. So in this case we get LA is equal to, that is the length of the top weld is close to 66.67 mm. The video you are watching is from the app, which is the Mohod class app available on Google Store. And in this app, we'll cover all subjects involved in mechanical engineering for GATE. Join the course directly from your mobile. The link is given here.